All right, welcome back. So we're going to talk to you guys about problem number 3 here, first order linear equations. So the whole goal with this is we're going to find ourselves some integration factors, okay? So let's go ahead and take a look at this. First one's pretty nice. Second one, I apologize. Third one should be pretty straightforward. All right, so what do we have here? We have 1 plus x, y prime. Go back to that. We have 1 plus x, there should be a y prime here, plus y, double check here, so plus y is equal to cosine x, okay, equals cosine x. Okay, so I know this is going to seem like a kind of a redundant step here, but our first step is always to clean off the y prime term. So we're going to have y prime plus y over 1 plus x is equal to cosine x over 1 plus x. So I'm a little worried at this point because even with integration factors, like this is a polynomial times a cosine, it's going to integration by parts, so I'm a little concerned. But let's go ahead and figure out integration factor first, and maybe that'll clear some stuff up. Okay, so my integration factor rho is equal to e integral of 1 over 1 plus x, okay, which is e to the ln of 1 plus x, which is just 1 plus x. Okay, so I knew this was going to happen, but so we're just going to multiply this thing by both sides here. Plus y is equal to cosine x, and it's it. You see, we got back exactly where we started from. I know. If you didn't see it from the beginning, then and you could have just guessed that this was the derivative of 1 plus x times y, and you would have gotten this, then that's how that's going to go. But, oops, I want to integrate cosine x here. So we're going to integrate the derivative, 1 plus x times y is equal to integral of cosine x, and what do we end up with? Well, we have 1 plus x times y is equal to sine x plus constant. So y is simply equal to sine x over 1 plus x plus c 1 plus x. No integration by parts. Life is good. All right. No initial conditions to solve, so that's it. We're done. All right. Okay. Pretty tame problem. Okay. Part B, and I wrote this down wrong when I did it, so it was a little bit harder than I did it, but I'll show you what I did, and then I'll just do the problem as written. Okay. So this is x, y tick, 2x plus 3y. Okay, we have x, y tick plus 2x plus 3y, and this is equal to 4x to the 4th on that side. I had an extra 2 sitting in here. I have no idea why, but that's when you see the problem. If you see the problem on the page, that's what I did. Okay, so let's go ahead and get rid of that. It doesn't really change anything. Either way, on this problem, you're kind of screwed. So first thing we're going to do, clean off the y prime. So we have y prime plus, we have 2x plus 3 over x times y is equal to 4x cubed. Okay, so that's going to be y prime plus, we have 2 plus 3 over x all times y, okay, is equal to 4x cubed. Okay, so get our integration factor, rho is equal to e to the, right? And we have 2 plus 3 over x dx, and we'll see how that works out. So that is e to the 2x plus 3 ln x, right? Be careful here, okay? It's not too bad, but if you forgot your rules of logarithms or forgot your rules of exponents, this can be a little tricky. So I encourage you to take your time with your steps so that you don't end up missing part of it. So this is going to be e to the 2x times e to the ln x cubed. Okay. Oh, actually, I take that back. This was a lot easier than the one that I did. I'm gonna have to rewrite that one. So e to the 2x times x cubed. Okay, that's how that works. So that's our integration factor. This is what we're going to multiply by. So we have e to the 2x times x to the 3 times y tick plus, what was this? This was 2 plus 3 over x, and this is going to be times e to the 2x times x cubed, right, times y, and this is equal to, it looks like 4x to the 6th e to the 2x. Yep, there we go. Now, let's go ahead and distribute this. Okay, so we have e to the 2x times x cubed times y tick plus, here we have 2x to the 3 e to the 2x, right? Plus 3 x squared, 3x squared e to the 2xy, and that is equal to 4x to the 6th e to the 2x. All right, not too bad. So that's going to be the derivative of, right, and this is e to the 2x times x cubed. Oh, sorry. Let's go ahead and group these guys together. Group the x stuff, group the y stuff. So this is going to be x cubed e to the 2x times y. Okay. Now, I encourage you to go through and just double check to make sure that this product rule, when we take this derivative, actually turns out to be these three terms. Okay, it does, but I'll say I'll be pretentious and say exercise is left as the proof is left as an exercise for the reader. Okay. So here we have 4x to the 6th e to the 2x. Okay, we got to go ahead and integrate both sides here. So we have x cubed e to the 2x times y, and this is equal to the integral of, we have 4 integral of x to the 6th e to the 2x. Okay. Now, clearly, I am not going to be giving you this particular problem on your final because it's going to take too long. Right? What we have to do here is integration by parts. Six times because of the x to the 6 here. Now, you had Calc 2 for me. I did not show you this on purpose. It is rare that you get problems like this. When you do, you can look it up. There's a ton of videos. Black pen, red pen. Black pen, red pen. Does a great job of showing how to do this. He's fantastic at it. I've noticed every time I've shown the shortcut to Calc 2 students, they use it for everything. It's like you can't use it for everything. You can only use it for stuff that it actually works on. Okay. So what we're going to do is you're going to make your sign. Okay, S-I-G-N sign, okay? And it just goes into an alternating pattern. It's plus, minus, okay? We're just going to type that in. Now, what were you going to take the derivative of? Well, in this case, we're going to take the derivative of polynomials. We're going to integrate e to the 2x's, but we're going to take the derivative of polynomials. So this is going to be, we're going to have x to the 6th. The derivative of that is 6x to the 5th. 6 times 5, x to the 4th. 6 times 5 times 4, x cubed. So this is a plus, minus, minus. Okay, it's easier with paper with lines on it. Plus, I'm going to say this is going to be 6 factorial over 2 factorial, right? 6 times 5 times 4 times 3. 2 times 1 will cancel. X squared minus 6 factorial x, and then we take the derivative of this, we just get 6 factorial. Okay. And then we have our I, and that's going to be the part that we're integrating. We're integrating whatever's left. This is e to the 2x. This is 1 over 2 e to the 2x. 1 over 2 squared e to the 2x. 1 over 2 cubed e to the 2x. Trying to see if it's important to, again, if you have problems with paper with lines, this will line up a lot easier. 1 over 2 to the 4th e to the 2x. 1 over 2 to the 5th e to the 2x. And 1 over the 6th e to the 2x. All right. And what we're going to do is we're just going to multiply these together like this. Okay. And we're just going to have a string of integrals to deal with. Okay. Let's go ahead and fill this one in. 1 over 2 to the 7th e to the 2x, and then of course this is going to be 0. So the next one is, we don't care, it's going to be 0. Okay, so this integral, right, this integral here, is going to be a lot. All right, so this is going to be x cubed e to the 2x times y is equal to 4 times this mess. Okay, so we have plus x to the 6th e to the 2x over 2, okay, minus 6x to the 5th over 2 squared, right, e to the 2x, okay, plus 6 times 5 times x to the 4th, right, over 2 cubed e to the 2x. See, isn't this delightful? I think I gave one Calc 2 student, or one Calc 2 class, like a thing where it was like x to the 6th e to the negative x. And then I think I've only done that once in my life. Okay, trying to think. I may not have even done it once in my life. I think I may have just explained to them what was going on. We did it, and I just showed them that this was actually just equal to 6 factorial. We integrated from 0 to infinity, but this was just 6 factorial. If you look on your Laplace transform sheet, you'll see the gamma function on there, and you'll see it defined like this, and that's what you do. Okay. So minus, and then we have 6 times 5 times 6 times 5 times 4 x cubed. So 6 times 5 times 4 x3. What do we have here? Over 2 to the 4th e to the 2x plus, so like I said, there's no way. I'm not asking you guys to do this because it's not going to happen. Okay. I think here we've got dot, dot, dot. Okay, so I'm going to go ahead and cheat a little bit, dot, dot, dot. If I gave you a problem like this where there's like saying terms like this, I'm not gonna begrudge you for doing dot 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 with this. It's too long of a problem. You got 2 terms, suffer, write them out. You got 6 terms like this, 7 terms. No, you can do dot dot dot. I'm not gonna get mad at you for that. This is 6 factorial over 2 to the 7th e to the 2x. Okay, so we're just going to divide, plus c. Don't forget the c. So the last thing we're going to do is we're just going to isolate the y. Okay, and we'll just have y is equal to, let's see here, x cubed. Actually, all the e to the x's are gone. So that's just going to be x cubed over 2. Right? Now what's my next term here is x squared, right? 6 over 2 squared x squared plus 6 times 5 over 2, 3 x to the 1, okay, plus 6 times 5 times 4, 2 to the 4th, oh, just no x's, plus 6 times 5 times 4 times 3, 2 cubed, oh, I forgot my plus, minus, plus, minus, plus, x to the negative 1, oops, 2, 3, 4, should be a 5, okay, plus dot, 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 and then we'll say plus c e to the negative 2x times x to the negative 3, okay, and that'll be our answer for that one. Okay, like I said, you know, if this one had like an x in it, just x, maybe x squared, you should write them out. Anything bigger than that, like, first off, I would not be interested in giving you that big of a problem for a final exam problem. I wouldn't be interested on a test problem, because there's too much to keep track of. Okay, but that's how you would do it, and I would encourage you to make a couple of shortcuts, like, you know, about in the middle, just not do it. Okay, you just write the first and the last. Okay, and again, this is tabular integration, and you know, this is exactly the kind of problem it's designed for you to do. Okay, and I'm sure there are some calculus teachers that, you know, think that like that is a perfectly adequate problem, because you only have to do this 7 or 8 times and you'll get the answer 7 factorial. Gamma function. Okay. That's how we get things like half factorial. All right, let's see here. We don't want to do any of this. Okay, and the one that I did, I wrote it down wrong. I had an x to the 9th. So not quite that, not that far gone. Okay, part C, right? This is 3C. Okay, nice problem. Y prime minus y tangent x is equal to sine x. Okay, it's already in standard form. Fantastic. Okay, so all we have to do now is e to the integral of sine x. So that's sine x, right, over cosine x. Negative, right, negative, because it should be a plus. Okay, so we're going to let u equal cosine x. du is equal to negative sine. Hey, it's almost like I got this out of a textbook and they planned it this way. Okay, so this is e to the integral. This is 1 over u du, because the negative takes care of the negative. So this is just going to be e to the natural log of cosine x. And then we're going to go ahead and say this is going to be cosine x. Okay. Even though we're not going to write it down, I am going to say it's going to be obvious that our differential equation solution is going to be in the interval where this thing actually exists. Okay, so we've got that going on. All right, so multiplying through. Okay, so we have cosine x times y tick minus y times tangent x times cosine x, okay, is equal to sine x cosine x. Okay. Let me just clean this up a little bit. So this is y, actually y tick cosine x minus y. This is sine over cosine, isn't it? And the cosines are going to cancel. Sine x is equal to sine x cosine x. Okay. So I only did that to make it real obvious that this is the derivative of y times cosine x. Okay, I think you can take that product rule by inspection and say, oh yeah, that is this. Okay, is equal to sine x cosine x. Okay, take the integral of both sides. Now, there is, hold on for a second. We have a thing going on. Oh, the joys of having a cat or toddler. Okay, so let's go ahead and do this. This is y cosine x is equal to, now there's a couple of different ways you can integrate this. I was always taught this way. Let u equal sine x, du equal cosine x. So this is the integral of u du. Okay. I have seen people multiply and divide by 2 to turn this into like a sine of 2x kind of a thing. I guess it's not too bad. But I don't know. Every time I see that, I kind of look at that. I'm like, wow, whoever taught you how to integrate, like, it was just a cruel joke for them, wasn't it? Okay. So divide both sides by cosine. Y is equal to 1/2. This is sine squared x times 1 over cosine x plus c times 1 over cosine x. And then we're just going to clean this up a little bit so that we can have a trig problem at some point and not worry about this. So this is 1/2. Sine over cosine is tangent x times secant x. Okay. And then 1 over cosine is secant. So times secant x. Okay, and there's my solution for that guy, right? So we'll call it there, and I will do some additional problems for us. All right, very good.